All right, so let's take a look at the muon experiment parts 2. We have these two different reference frames. Let's bring back this chart right here. We have two different reference frames here. We have the muon reference frame and the Earth's reference frame. Now on Earth, we made the claim that that is the amount of time that the muon was traveling. From the muon's point of view, it traveled this time right here, which is basically almost a tenth. It's a factor of 9.14 difference between the two. And so there's got to be something else. Upon what do they agree? Well, they both agree something is traveling at 0.994 times the speed of light. They disagree on what's traveling that. So the Earth, from the Earth frame, they claim the speed of the muon is 0.994 c. And from the muon frame, they're making the claim that the speed of the Earth is 0.994 c. That would be the distance divided by distance over time, and this would be the distance. This is the distance that the muon travels over time, and this is the distance that the Earth travels over time. This time right here is the muon frame, so that's the proper time, and this is the Earth frame. So in this particular case here, we have the distance that was traveled. It's just going to be the speed of the muon from the Earth's point of view times the time from the Earth's point of view. And the speed that it's traveling was 0.994 times c. And the time was 6.37 microseconds. Over here, the distance that the Earth is traveling from the muon's reference frame is equal to the speed of the Earth times the proper time, which is 0.994 c from the muon's point of view, times the proper time, which was 0.697 microseconds. So notice that the distances traveled are different. They disagree on what traveled that distance, and they both disagree on the actual distance traveled. So, matter of fact, the difference between these two is gamma, that the distance that the muon travels from the Earth's point of view is going to be equal to gamma times the distance that the Earth travels from the muon point of view. So if we put it back in terms of proper frame that we established earlier, that T is equal to gamma TP, where this is the frame of the non-moving reference frame, well, think about what's not moving here. You're traveling from the top of a mountain to the bottom of the mountain, from here to here. Well, it's actually not moving in the Earth frame. From the muon's point of view, the ground is coming up towards it. From the ground's point of view, from the Earth's point of view, that ground hasn't moved at all. It's the muon that moves. And so, therefore, the distance, the Earth's point of view is the proper frame for distance. So here we have not. So delta x proper is equal to gamma times delta x. And so even though that the proper seems to have flipped sides, they haven't. Both of these are from the muon's point of view. Both of these are from the Earth's point of view. And we actually end up with these two generalized equations right here. And so this is known as length contraction. And that's the end of that video.